Okay, now I know who played the game.
I saw it play out.
I've never played it.
Well, honestly, I never have, but I've seen it.
My Alex plays it, and he's shown me things, and I have former students who did some cards, you know. But yeah, I have plenty of nerdy history. All right, so you guys, I'm going to do this with squares, okay? But this also works. This also works with rectangles. And here's how wonderful diagonals are. Okay? First of all, if you have a square or a rectangle, actually everyone just watch for a second, because this is going to happen really fast, and you're going to totally get it, and then you can, do it in your notes in a second. So if I have a square or a rectangle like this, and I bisect it diagonally, I find the center. Okay, you guys, that makes sense, I hope, to all of you, basic geometry stuff. It also means that using verticals or straight lines or horizontal lines, I can also find the midpoints of each side. Okay, that's another thing I can use them for. But now here's where it gets really cool. If you want to multiply this original object, you can draw from here, watch carefully, through here, through the halfway point on that side, and you get exactly one more square. And you can do this ad infinitum. On and on and on and on and on and on and on. Okay? Catch up to that point, and then I'll show you even cooler stuff. All right, now let me show you some cool implications of this. This is the one, this is the example. You'll see this in a lot of perspective books, but what you won't see in all the books is some additional things that you can use diagonals for, or things you can do with these diagonals, things that you should keep in mind when you're, this is a great, I love these kinds of tips or these kinds of methods because they don't have to have mechanical tools. You can use these sketching just as easily on location as you would mechanically. You know, unlike the station point or measuring points or things like that that are more mechanical. All right, so watch this, you guys. So I can do that, and I can do that till the cows come home, proverbially. You know, I don't actually own any cows. But you can do that, or you can do this. This is cut in half. If I cut it in half again, I quadruple it. Watch, wait, it gets better. Cut it in half again. Go ahead. So it's cool stuff. And actually, let me show you just one more thing. I can even do this. Watch. Oh, I don't need 8, I need 6. Because I just found the midpoint between 4 and 8. So I don't want you guys to think of diagonals as diagonals. I want you to think of diagonals as a tool you can use to multiply. Eureka, could you help Matt? Can you help Matt out? Matt's had a question. So I want you to think of diagonals as a drawing tool that you can use to multiply or divide with. They're really incredibly useful. And actually, I'll show you just how useful in a second. Need help? What? Let me know.
Okay.
It's some powerful shit.
It clicked.
All right, you guys, and here's what's so cool about this. Here's what's so incredibly cool about this. Eyes up for just a second. If it works here, this is a general principle of perspective. If you can draw it in 2D and make the geometry work, you can draw it in 3D and make the geometry work. So if I go like this, everyone just watch this for a second. So I'm going to estimate a square is here. So there's my initial square. Question? Oh, that's because you're not being accurate enough. Actually, what's happening is, do you see how this line is going like this?
Oh, yeah.
That's what's causing it.
Oh.
Okay, so you guys, what's happening? Actually, let me show that under the downstroke. You guys, this is why, remember how I was telling you guys you need to be really accurate and you need to practice drawing straight lines and stuff like that, and you need to really watch your angles? See how these are getting longer? The reason why is because this middle line isn't actually in the middle. It's veering off, it's kind of going, and so as it does that, it keeps lengthening the line, and that's increasing the mistake. So anyway, so you guys take a look, watch this. Here's my initial square. Watch carefully, eyes up. I bisect it. Go to the vanishing point for the midline. And then we do the same thing we did. Now here I'm being a little careful because I really want it to work out correctly. Now these things can be fence posts, they can be windows, they can be anything that has a regular interval. Sidewalk panels, panels on the side of a room, etc., etc., etc. You see what I mean? Now again, same thing, if I cut this in half.
Are you just eyeballing the halfway point?
I am eyeballing the halfway point, yeah.
Okay.
This halfway point I'm not, but this one I am. And then this one I'm eyeballing it again. Now, I can eyeball it because it's a vertical. So it's not foreshortened, so I can pretty much trust it, you know, that I'm doing it accurately. Now, if your judgment isn't that good, well, get better. No? So like, this is the 8 mark. You see what I mean? If I want to find that 6 mark again, I can do the same thing I did before and go, okay, there's the 6. So anything that works up here will work down there too. Okay, go ahead and take some more notes. And also realize this not only works with squares, it works with any rectangle.
Where did you go to get the ×3 again?
Oh, I'm gonna show that next. I'm gonna show, oh, you mean for this one here?
Yeah, right there.
I basically, from here through here gives me 2. From here through here gives me 3.
Oh.
From here through here gives me 4, etc. Yeah,
If you wanted to translate something that had spacing in between, like you have a window and you have a wall.
yeah. What you would do is you would work it out as a subset. So you take one window and one division and multiply that and then cut it. You know, so you would do it that way. There's also other ways.
Then you'd have to calculate the
Right. You'd have
window.
there's about 4 different ways to do that. You can do it. You choose which method you want to use depending on the situation you're in. Like, you can use a quote-unquote vanishing point,